Hey everyone, so we are continuing with finding the area under the curve using Riemann sums. We're basically just going to do a review of all the four different methods and also some definitions and new notation. The hardest part with this is we just create new notation constantly with this lesson. Okay, so the area under the graph of y equals f of x, I did it again where I have b as in b from a to b is obtained by finding the limit as n approaches infinity of that sum. So remember, this is your width. The delta x is your width, and then you're plugging into the function, this is your height, right? So n is the number of rectangles. So the limit as n approaches infinity, so basically we're having an infinite number of rectangles. So the rectangles are so small, they're basically just a line, right? They become so tiny, they become a line. So this is called the definite integral. So let f be a function defined on the closed interval. We partition into subintervals, so that's your rectangles. If the limit of the Riemann sum exists and does not depend on the partitions, then the limit is called the Riemann integral, or definite integral of f from a to b, and is denoted. So basically, instead of writing out, okay, we're adding up all these rectangles, this is our notation, and that just means find the area under the curve. So that's our function, find the area under the curve from a to b, right? This dx is just another way of saying delta x. When the above limit exists, then we say f is integrable, so you're able to take the integral. Okay, so we have the integral, it's that squiggle from a to b, looks kind of like an S. A is the lower limit, b is the upper limit. That symbol is the integral sign. F of x is our integrand, and this is called the dx is the differential. So that's your delta x. That's the width of each rectangle. Okay, so instead of saying find the area under the curve, they're just going to give you the integral from 1 to 9 of x minus 3 to the second. So we're going to partition this from 1 to 9 into 4 subintervals, each of length 2. So pause the video and find the area using the left Riemann sum, a right Riemann sum, a midpoint, and a trapezoidal. All right, so I don't usually, when I'm doing this, I don't always draw the whole graph. I usually I like to do this, 1 to 9, and it's length 2. So this is 3, 5, 7. Right, and then, I mean, if we want to draw it, we can. It's going to look like this. So for my left Riemann sum, my width is 2, right? And then from the left, if you didn't pause, make sure you pause and do these on your own. So from the left, if I plug in 1 into that equation, what do I get? I get 4, so 4. If I plug in 3, I get 0. I plug in 5, I get 4. And then I plug in 7. 7 minus 3 is 4, so that's 16. So I'm just plugging into the function, right? So 4, 0, 4, 16. And then if we plugged in 9, that would be 36. So I get, what's that? 24 times 2, 48. And then my right Riemann sum is 2, and now we're starting from the left, starting from 9. So that would be 36 plus 16 plus 4 plus 0. I don't have my calculator on me. So let's see, that's 40, 56 times 2, 108. And then midpoint, so midpoint, now I'm plugging in, so it's still 2, right? But instead of plugging in 1, 3, 5, 7, and 9, I'm going to plug in 2, 4, 6, and 8, because we make these, it's a little under, a little over. Right? So this is my midpoint. All right, so let's see. If I plug in 2, I get 1. If I plug in 4, I get 1. I plug in 6, I get 9. And I plug in 8, I get 25. So let's see, that's 36 times 2, 72. And then trapezoidal. So trapezoidal, that's 1/2. And then I have the base 2. And I usually just write out all of them. I think it's easier. So I'm just going to do my 1/2 to 4 times. Because the trapezoid is 1/2 times the width, which is the 2, right? This distance here. And then the 2 heights. All right, so if I'm starting, I'll start with 1 to 3, right? The 2 heights there are 4 plus 0. And then I got the 3 to 5. The heights are 0 and 4. Then I got 5 to 7. My heights are 4 and 16. And then 7 to 9. My heights are 16 and 36. So in this one, nicely, those all cancel. So we get 4, 4, 20, and 52. So that's 80. So we get 80 there. And that's my 4 methods. All right, same thing. Pause the video, try it on your own. Okay, so this one we're doing 3 subintervals. So I'm going from -4 to 5. And it's nice that the square root starts at -4. So it's going to look like this. Okay, so that's a distance of 9, so it's every 3. So -1 and 2. So there are my rectangles. And then I like to plug in right away. My y value here is 0. My y value here is √3. My y value here is √6. And my y value at the end at 5 is just the integer 3. Okay. All right. So the distance between each of those is 3. So we're starting with our width of 3. And then I'm starting on the left. I plug in -4. I get 0, √3, and √6. I'm just going to leave it like that. 3 times √3 plus √6. You can find the decimal if you want. I don't want to. It's too much work. Then I'm going from the right. So this time we're plugging in 3, √6, √3, going backwards. Again, I'm just going to leave it like that because I don't want to do anything else. I'm going to jump to trapezoidal because the midpoint I have to do more work. Okay, so for trapezoidal, 1/2, my width is 3. And then 1/2, 3. I'm going to do back and forth this time. 1/2, 3. Okay, so I've got 0. The -4 and the -1 gives me 0 and √3. And then √3 and √6. √6 and 3. I don't even know how to do that. 3/2 √3 plus 3/2 √3 plus 3/2 √6 plus 3/2 √6 plus 9/2. 1. So 6/2. Oh, 6/2 is, oh, so that's 3√3 plus 3√6 plus 4.5, or 9/2. Cool. Okay, midpoint. So midpoint, I'm plugging in. So I got that guy, this guy, this guy. Oh, this is not going to be good. Ugh. Okay, so because it's an odd number, the midpoint from 2 to 5 is 3.5. So I have to plug in 3.5. I have to plug in 1/2. and -5/2. So because we're plugging in the midpoint. Okay, so this is 3 times, if I plug in, what does that say? -5/2. So -2.5, that's the square root of 1.5, plus the square root of 4.5, plus the square root of 7.5. That's terrible. We're just gonna leave it. Whatever, who cares? That's my answer. I'm good. So now I'm kind of skipping this, but it's really common on the AP test. They like to see, like for the left Riemann sum, instead of just writing this, they really like to see like f of -4 plus f of -1 plus f of 2. So on the, we'll do more of that. I didn't do it here, but on the AP test, they like seeing this work so that they know that they know that you know what you're actually plugging in, right? So that is something that they show a lot on the answer keys. All right, one more, sine. All right, 0 to pi. What am I even doing? Pause the video, do it on your own. Oh, I was drawing a sine curve, that's right. All right, so we're only going to pi. And then 4 subintervals. So this is pi over 2, pi over 4, 3 pi over 4. Oh, this is gonna be gross when we do when we have to do midpoint. Oh well. All right, so I'm gonna figure out my y's. So at 0, I got 0. Pi over 4 is √2/2. Pi over 2 is 1. √2/2 is 0. Okay, so what's the width of each of my rectangles? So pi over 4 is the width of all my rectangles. So then from the left, we're starting at 0. And then we got √2/2 and 1. So again, there's nothing to, like, I know you guys like decimals, you don't like leaving it like this, but this is a completely fine answer. I would just leave it like that. It's like, no one cares. Just, it's fine. All right, right from the right is going to end up being the same thing because of the symmetry of this guy. So it's 0 plus √2/2 plus 1. Because we're starting on the right side that has 0 also. So pi over 4 times √2/2. I mean, if you want, you can turn it into one big fraction. So that would be pi √2 plus 2 pi all over 8. Honestly, that's the most I would do. I don't feel the need to do anything more than that. Unless you like want to know what's the area under the curve. Okay, trapezoidal. Again, I'm going to do Riemann last. So I have 1/2, and then what's the width of each of my rectangles? Pi over 4. Oops. Okay. And then 1/2 pi over 4. And then whatever we're adding. I'm just going to make that's pi over 8. Pi over 8. All right, so from my first rectangle is 0 and √2/2. My next one is my √2/2 and my 1, right? So this is that's my trapezoid, if you look up. This is the height of the pi over 4, and then my two bases are the 1 and the √2/2. And then we get another 1 and √2/2, and another √2/2 and 0. So pi over 8 times, what we can do to make it easier is just pull out a pi over 8 for all of them, and then I'm going to add all my √2/2's. So those give me 2 √2. And then I have my 1's. There's 2 1's, so plus 2. And that's it. And then my 0's, which is 0. Okay, so that is my trapezoid. And then again, if you want to distribute, you could do 2 over 4 pi plus pi over 4. That could be your final answer if you want. All right, midpoint. It's still pi over 4, but we have to figure out the midpoint. Ooh, I don't know pi over 8. So what's halfway between 0 and pi over 4? Well, that's half of pi over 4, so that's pi over 8. I have no idea what sine of pi over 8 is. Sine pi over 8 plus, and then what would that be? So we're adding pi over 8, so that would be 3 pi over 8. All right, 3 pi over 8, 5 pi over 8, and 7 pi over 8. Ooh. I'm just going to write these like that. Sine of 5 pi over 8. Sine of 7 pi. I skipped one. Oh, 3 pi over 8. It's because I'm writing so messy. And 7 pi over 8. I mean, I have no idea what those are. I'm sure I could figure it out. Use like the half angle theorem or something, but I have no idea what that is. They wouldn't expect you to know that on the AP test. So you can leave it like that, just write it all out. Or if you want to grab your calculator, just make sure you're in radians. Okay, so take a picture of page 402. That's what we're going to be working on in class on Tuesday. Have a fabulous day.